Welcome back to geometry. For our next construction, we would like to construct the not perpendicular, don't need perpendiculars anymore. We're interested in the bisector of an angle. So we want to construct the bisector of an angle. So if we have some angle, A, B, C, we want to construct the bisector of the angle. Now, when it comes to the bisector of an angle, we've discussed a little bit before about what points on the bisector look like, or some of the characteristics. For example, we know that for a point on the bisector, we have that it's equidistant from the sides of the angle. That gives us two congruent triangles. So we want to use this idea, we want to use essentially these triangles that we could create to find, and instead of them resulting from the bisector, we want to construct the triangles, and from the triangles get the bisector. All right, so we won't go quite so far as to make sure that these are perpendicular like we would find we may have found or mentioned previously, but we will measure out from our sides. All right, so to find our bisector of the angle, the first thing that we're going to do is we're going to find these points here. You could think of it as. So we want to construct the circle centered at B with some radius greater than 0. That's going to give us some intersection points. We'll call them D and E. Now from there, if we find a point that's equidistant from D and E, we would actually find that that has to be on the bisector. So let's see here. In order to find a point that is the same distance from D and E, we simply create two circles at D and E of the same radius and look for where those intersect. So we want to construct a circle at D with some radius and a circle at E with the same radius to get the intersection point, call it P. Then the line we can construct from finding that additional point, BP, right, a vertex through that point P, that is the bisector of the angle. And let's give some justifications of that. So first of all, from the definition of a circle, when we construct the circle centered at B with some radius, we get that BE and BD are equidistant apart. So BD is equal to BE. But we also have that DP is equal to the radius S. Because we're looking at two different circles here, we don't immediately get that EP and DP are the same. But we have that EP is equal to the radius and that DP is equal to the radius. Those are all by the definition of a circle. So once we have that, then we know that EP is, that DP is equal to EP by the transitive property of equality. All right, so what does that give us? Well, nothing quite yet, but we should recognize that the distance from B to P is equal to itself. Which gives us side, side, side of these triangles that we have constructed here. So this is the reflexive property of equality. And then we have that the triangles that we have created, BDP and BEP, are congruent. And that's by side, 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 where we considered BD and BE are the same, DP and EP are the same, and BP is equal to BP. All right, so now that we have congruent triangles, we have that this angle measure and that angle measure must be the same. So we have that, if we call, well, let's just say angle PBD is congruent to angle PBE. That's by the definition of congruent triangles. And once we have that, we know that BP bisects the angle. Excellent. Definition of an angle bisector. All right, so what does that look like when we're actually drawing it out? Right, this was the motivation. That's not what we actually do for the construction. For the actual construction, let's go ahead and start with an angle. So we might have an angle that looks like this. And we want to construct the perpendicular keep saying perpendicular because we've been looking at them like crazy. We want to construct the bisector of this angle. So what I'm going to do is I'm going to find a circle of radius non-zero, right? Some positive radius, giving me these two marks. So if I wanted to draw the complete circle, it'd look like that, but all I'm interested in is those two marks. So from here, right, I can label those points as D and E. And then I want to construct from those another triangle. So let's actually, or not a triangle, but a couple more points from circles. So I want to construct a circle at D. And what you might do, right, you might just make it a reasonable length that goes out and further into the interior of the angle, and that's fine. Try to reach out, or we use a circle of the same radius and reach out from E. So we create the circle around D, and we create the circle around E, giving us these points, right? That we only need to make these marks. That's all that we're interested in, because those give us the intersection point P, and from that we have the angle bisector. Awesome. So that is the construction of an angle bisector. Join me again soon for our fifth construction.